Desk Ladyada.
Hey everybody, welcome to Desk of Ladyada. We're hacking here, some hardware finding my little stickers on me. All right, doing some hardware here at my desk here on this lovely Sunday evening. It was really beautiful out. Don't forget, folks, this Tuesday, Adafruit is closed because we give everybody the day off for voting. So if you want to order something, and you order it on Monday, it'll ship out Monday. Unless it's later in the day, it'll ship out Wednesday because again, Tuesday's a voting day, and we give every Tuesday off as a float holiday. Okay, cool. And sorry, and Veterans Day as well. So next week is a bit. We also give that day off. So next week is a little bit short. Get your hardware from us, or of course from DigiKey, and they'll ship it to you immediately as well. So that's the news and updates. So why don't we? You want to go to my desk, and we'll get right to it. Okay, first off, doing a lot of revisions. And if you remember last week, I talked about doing the revision for the 3.5-inch TFT Featherwing. Here is the old version. So this version used the STMPE and had a fan 5331 boost converter. New one, you'll notice there's no gigantic diode anymore because I'm using the TPS 61129. I think it's part number. SOT 89 version of the boost converter. Boost converter has been working great. I've been using it in a bunch of stuff. So replace the backlight driver with that. Touchscreen converter is now TSC 2007. Also changed the reset button from vertical to right angle. Same on-off switch. Added a STEMMA QT port. Shoved everything over a little bit. Same micro SD. And, now we've got this going. Show the demo with the TSC 2007, and it's working great. Only thing is you saw, like, one thing I forgot is to pull up on the backlight controller. Don't, like, you need to have it activated on. So, fly away. So this is the touch screen. Hold on, let me press the reset to clear off that little chunk there. I can draw just fine. Gonna do swirls, different colors. Touchscreen's working great. So this hardware is good. I have to do the Pi TFTs after this. Those, I also would love to do with I2C, but we'll see if that, I don't know if we were able to get the device tree overlay working very well with the TSC 2007. So we will check it out. Let me just move this. Okay. So this revision's done, and I'm actually like, this is going to be my 500th revision, or close to 499 or 501. I think there's a couple. I might have missed one or two. A lot of revisions. You'll notice a lot of new photos on the site because pretty much every product had to be revised because a chip got discontinued or is end of line. Diodes, transistors, voltage regulators. I moved almost all my voltage regulators from the AP 2112 because it wasn't available to the AP 2127. So almost pretty much everything got components swapped out. But pretty much everything's worked, so, I had one or two items didn't make it through test, but we caught, before, we did a first article and we're like, oh, turns out I thought this was an okay swap, but it wasn't an okay swap. Revising, at first it was kind of scary because there's nothing worse than revising something that you've had for 10 years because so many people are relying on it that you're like, oh no, I hope I'm not making a mistake. It's a popular product. We sell thousands of them. I don't want to get this wrong. But so far, hasn't been too bad. And then, oh, what's funny? I have the next thing I was going to show. Hold on. Intermission. I'm just going to grab it over there. Okay, are you back to the concession stand? Great. I've got the tester. I put it away because I'm gonna bring it into the office for the Metro ESP32 S3 Rev B. So it took me I had a couple weeks. I just couldn't get to it. I had to revise this before it even got really out into the store. We put it into the shop, and then I realized that I was using the OPI PSRAM pins for SPI, and they were not, you can't, because they're used for PSRAM. And my test, when I test hardware, I test it in Arduino. And so I had enabled the PSRAM, and the PSRAM was like, yes, I'm running and I'm detected. And then later on, I would, in the test program, I'd have it connect to the SD card. And the test passed because after the PSRAM was initialized, I never used it. Like, I tested it to see, like, hey, can I communicate with you? The PSRAM said, yes, you can communicate with me. And then I never talked to the PSRAM after I configured it for the SD card. So I didn't realize that those pins were unavailable. This was like my first design with the OPI, Octal PSRAM Metro M, ESP32S3. Learned that lesson. And then, of course, that when it came to the Qualia board, that was good to know that those 3 pins were not available. I think it's like 35, 36, 37. ESP, I love the chips, but there's always, like, you really got to watch out for those strapping pins. They expose pins that are like, hey, if you actually use this pin, like, really bad things are going to happen. And I've noticed that they've stopped doing that on modules. Like, if a pin is used internally, they don't, and there's really no reason for you to have access to it. They don't give you access to it, but it's, lesson learned. So this version is Rev B. It has that fixed. The test procedure is working and done. We got a little bit of a USB race condition, but TAC fixed it in TinyUSB. Another thing I noticed is, unfortunately, I did a PR to update the pins for this in the Espressif board support package, but then, like, the next day they did a merge update with, like, some ESP board support package 5.1 thing, and they actually ended up blowing away my changes. So I'm going to do another PR to fix the pins, because, again, the old SPI pins are no longer used. They've been swapped out. Hopefully this Rev B is done. There's just really all the pins. The Metros use a lot of pins. Like, all the pins are used, and so it's there's no, like, I had to start using pins that are normally not recommended, like the SPI voltage selection pin, and like the NeoPixel is driven by, like, the debug output pin, which we don't use on this this board. So, I think next week we should be able to put the Metro S3 in the shop. I really love this design, so I would love to get it into the shop. If anyone out there has a Rev A, we'll replace it with a Rev B for free, obviously, because the Rev A was, like, totally a mistake. Learned my lesson, though. What's funny is that when we tested the Rev A on CircuitPython, and it was hard faulting because of the pin misusage. But because we'd been having so many weirdnesses with the S3, I was like, oh, I thought it was a different bug that I was seeing. I didn't think it was related to the Octal PSRAM. Lesson learned. Okay, and then some other stuff. Speaking of Octal PSRAM, the Qualia board. So thanks to Melissa, we have now a touch screen. Whoa. A touch screen driver for the 2.1 inch. So most of the touch screens for these large displays are CST, FT6336U. That's like a very common one, or similar. Yes, this is the next rainbow demo. Of course, it looks great in person, and screen through screen. Screen looks a little bit flaky, but it looks really good in person. And so now, when you do touch, the capacitive touch works. So thanks to Melissa, who wrote that chip library for it's like CST 622 or something. I can't. Ever since we moved from printing to laser etching part numbers onto chips, it's very hard for me to read them. You have to, like, get them right at the correct angle. But if you have one of these screens, we now have a touch driver for it in Arduino and CircuitPython. So thanks, Melissa. So the next thing I'm going to do, I have a couple more sample displays, but, like, this board is pretty much good to go. So the next thing I'm going to do is I'm going to make a version of this for RGB 888 displays, because I have a bunch of those that we stock, and I want to get some nice, like, IPS versions of those screens and capacitive touch and stuff. The only thing is that a lot of the RGB 888 screens don't have this nice cap touch through the main connector. They usually have, like, a separate little tail that has the capacitive touch. And so, and the pinout for that tail is not standard. Like this has a standardized, like capacitive touch is always the same pins, the RGB, same pins, H-Sync, V-Sync, but the 888, the 800 by 480 rectangular displays, the 40 pin connector for the display, standard. The capacitive touch, not standard. So I might start with a version that supports resistive touch because that is a standard pinout. And so I'd have a resistive touch like the TSC, you know, the TSC that I use here. This driver, I would stick this on here and use that for the resistive touch. And annoyingly, I think I still need to have the IO expander, even though I'm not using it for controlling the SPI pins to do the init code stuff, because I still need these buttons. I need the IO expander for the buttons and for the TFT reset and the TFT backlight, because there's so few pins available, and I want to keep all these GPIO down here. So that's okay, but you know, we're making slow and steady progress in all these displays. You know, part of it is just getting the init code going, getting the example code for everything, and then we're gonna do more with these. So that's probably the next step for this board. And then lastly, before we go into the great search, I'm back to working on my camera board, which I've been, you know, slowly working on and off as parts have been available. So RevD has moved. So I had all of these power supply components. I had the power supply down here, but actually didn't make as much sense to have it down here because the things that were high current was like, you know, the backlight and the ESP. This camera does take a lot of power, but I wanted to actually keep the power supply away from it because this is temperature sensitive, which I've noticed. The camera modules, you'll notice this one's like metal, and you stick it on, and I try to heat sink a little bit through the ground plane on the back. But they're, you know, they can use, when it's running and like streaming the preview image, it can draw like 200 milliamps. And so I also replaced the 3.3 volt LDO with a little buck converter, and I'm using the TPS. It's the whatever the one I have in the shop. It's the TPS 629 or something. 2 amp, like 1 megahertz buck converter, and it's like very cheap. It's only like 20 cents. We covered it on a previous great search for sure. And then, you know, the 1.5 and 2.8 volt regulator. But you know, this, you know, this fits underneath, and then the preview screen is here. And so then I've also got a little faceplate I've designed that looks like this. So the face paint, you know, what I really like about having these SMT nuts that, you know, you pick and place on, like they're pick and placed on, and you can get to them from the front or the back. And so from this side, I use just plain machine screws, and from this side, you just add a hex nut as a spacer, and now it's not screwed in. Hold on, let me see if I can. Yeah, okay. You can screw this in. Beep 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 beep, and it becomes a nice little faceplate. Only thing I realized after I did this is that you know, the buttons are nice now, like they don't, you know, they stick out a little bit, but the you can see in the middle the speaker is a little taller than I thought, and so I'm gonna have to add a cutout for the speaker. I had little speaker holes, but I have to add an actual cutout instead. Okay, and then so you see here, so the last thing I did is the front plate to protect the circuitry. So like, you know, this is exposed. So I have a little front plate, and I was like, oh, let's add like a NeoPixel ring. I think like, you know, Phil B and I chatted about this, and we're like, oh yeah, like let's make a plate that can have a NeoPixel built into it. And I picked RGBW NeoPixels. The final version will be black, of course. This is just green because it's fast started to get green. And, you know, I wrote a little demo that will do RGB and then white. So I don't know if I can. do this. It's upside down, so I can do that. Okay, so then hold on. Okay, so you can see like the color coming through a little bit. Like I'm kind of close, but you know, I thought this could be a neat demo for the focus. I'm asking a lot of this camera right now. Oh, there you go. Okay, so I thought this would be neat because first off, it can act as a flash, but it also can do like some cool like rainbow ring light effects to, you know, like colorify whatever subject, you know, like a portraiture or like a pet or something, or like you know, but something nearby. Obviously, it can't throw the color very far, but it can, for close-ups, it can do a neat color effect. And this is like one of the things that you can't get with an iPhone camera. Like, you know, not only is it like a hackable camera, but I wanted to do something that wasn't just like, well, my iPhone can do that. So your iPhone doesn't have a ring light built in, but this one does. I mean, you can see the color effect on my face. Okay, so that's my hardware hacking for now. All right, so this is kind of cool. You can see like the, hold on. You can see the reflection of the ring light. Pretty bright. 8 NeoPixels is quite bright. And I love that they're RGBW. The reason I went with, oh, and then of course it's battery powered too. The reason I went with RGBW is so, you know, when you want the white light, it's extra bright and it's like a pure natural white. Okay, so that's my desk. I know, a lot of hardware. All right, let's go to the great search.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thank you, DigiKey. Every single week, Ladyada user power of engineering help you, yes, you find the things that you need on digikey.com. What is a great search of the week?
Okay. So this week, you know, one thing I do before we, you know, do the show is I always look like, oh, what, you know, I search social media for like find or search and the word DigiKey and just be like, hey, somebody was like, I can't find, I'm looking for something on DigiKey. And, you know, some of them actually already covered, like somebody was like, oh, I need machined pins. And I was like, I already covered that. I was going to do that as the great search, but we already did that before. But this one was kind of interesting. So I've never heard of this material before. So people who are doing like overclocking of CPUs and GPUs, you know, you need to water cool or like air cool the CPU. Like, you know, the Pi 5 now has an air cooling add-on, and you know, you have this cooling fan or this heat sink, right, or this water cooler, and then you have the CPU itself, and you have to attach the CPU to the thing that's cooling it, and you want the thermal transmission to be as good as possible between the two. And traditionally, people use thermal paste. And yeah, thermal paste, I don't know if anyone, like, if you've ever put together a computer, it comes in like, you know, you get your CPU kit, you put the CPU down, and then you squeeze this stuff, and you kind of like, you know, slurp it around, and then you clamp the heat sink on, and like there's these little clamping bits, and the paste fills in the gaps and makes like a near perfect thermal connection between the heatsink and the CPU. And so apparently there's this other kind of material called thermal pads. So I've always used paste, but I have seen thermal pads once in a while. And thermal pads are, as you can imagine, very thin pieces of material, and they're less messy than paste. And you never have to clean it off. You stick it on, remove it. And they have a benefit of, they can also be a gap filler. Like if you don't, you know, one of the risks of clamping the heatsink onto the CPU is like you clamp a little bit too hard, you could crack the CPU. You want it to be like exact, but like exact, no more, no less. Too big, not enough thermal transfer. Too little, you just like destroyed your CPU, and that's really tragic. So thermal pads, you know, they have a little bit of give. And the one that they're talking about in particular is called CryoSheet, and like I have no skin in this game. I don't know anything about this product or what this is used for. So I'm just, you know, NB, nota bene. I'm not an expert at this. But you know, this is, you know, $15 for a 1" by 1" sheet. And I was like, oh, well, I'm going to look up and try to find the specifications for this. You know, like what is the thermal resistivity of it? And there is no published thermal resistivity. And so again, I know nothing about this market, but let me tell you as an engineer, if you're buying a product like this that's meant for thermal heat sinking or like thermal transfer, and there's no specification, there, like, you can't know if it's any good or not, because it isn't like thermal resistivity isn't a feeling, it's a number. And so if the number isn't there, there's no way for you to compare it. And I think that's part of their thing, is like, you know, they don't publish the number, they just say it's the best, and you just sort of have to trust it. So let's show how you can find on DigiKey graphite thermal pads that do have numbers published with them, and so you can actually compare them one to the other. Okay, so go to DigiKey, and you know, is it better than this other cryo thing? I don't know, but I'm going to show you how to find the real deal, and then, you know, you can compare and contrast and do testing with it. Okay, so let's look for thermal pads. So they've got it. Pads and sheets, 8,000 items. And I'll say, you know, they have, like, of course, heat sinks and peltiers, you know, active coolers, water cooling, thermal paste. But pads and sheets, again, they're easy to apply. Like, you know, if you want to remove them, adjust them, you know, paste is going to probably be better because it's thinner, but for the raw thermal transfer numbers, but there might be times you want pads and sheets. Okay, so as usual, we go to stacked, and we're going to only look for active items and then in stock. Just not that there might be stuff, you know, that is better that's not in stock, but we only want to see what's available. Next up, you know, I don't think we care too much about the acrylic adhesive. You know, maybe you want adhesive, maybe you don't. Maybe that's not as important. But we do want is the thermal resistivity, and we want to have like the lowest thermal resist. Well, sorry, let's look for the thickness first, because the thickness was kind of, you know, an important thing. So sheet size. So these are 0.2 millimeters thick. So let's look for about 0.2 millimeters. So if you go here, you can see this is exactly 0.2, but let's be a little bit flexible, you know, maybe up to 0.25, maybe as low as 0.15. So we have, like, you know, a range where we want thinner sheets in general. Okay, you'll notice for if I select graphite, the thermal resistivity for, you know, graphite is going to be the lowest ones, but let's, instead of just, you know, specifying graphite, just in case there's like other materials, we're going to just go with, you know, the lower, maybe the, you know, low, you know, 0.5 degrees C per watt or lower. So that gets us down to 42 options. And so you'll see, like, there's some very low cost ones that are, you know, 70 cents. But these are small. They're designed for TO220. So there's, when you have like specifically a TO220 LDO or transistor or IGBT or whatever, and, you know, you don't want to like cut and drill a little hole for the, you know, the back part of a TO220 is like that nice flat metal heat sinking part. And you put that between that and the heat sink, and then you use a screw to connect it. And that's what that hole is for, is that's where the hole goes through, the screw goes through to clamp that transistor or LDO to your heatsink with a little pad in between. But we don't want that. We actually want like something like this, because we want to be able to cut our own pieces out. Although I'll be honest, like, you know, if this is the right, you know, if the TO220 pad happens to be the right shape and you don't mind the hole, or we get a version without a hole, that's fine. But let's look at larger pieces. So if the cryo sheets, you know, they do have a small 24 by 12 millimeter, but I actually think like most chips are, you're gonna, like a GPU or CPU, you're gonna want to have at least 1 inch by 1 inch, if not more. So let's, in outline, let's just only pick at least, you know, 1 inch on one direction, but you'll notice that there's going to be a lot bigger ones. And then finally, there's a lot of marketplace options as, you know, pieces as well. So maybe we'll get rid of the marketplace, although these are, you know, you can always get these pieces if you want. Those can take a little longer to ship. So let's just look at what's available in stock. And looks like there's a couple options for, you know, thickness. And the thermal resistivity, you know, I think we can look for the lowest resistivity. So we'll start from the bottom up. So this is the most, these are the best pads for resistivity. So this is kind of a vague one, but it looks like it's just like a gray pad. This one is pretty inexpensive. These are rather large. This is 600 by 450 millimeters. But this one is fine. You know, this one even has adhesive on it, and 450 by 300 millimeters. You compare that against, you know, these sheets that are like, you know, $20, 1 inch by 1 inch or something. This piece is, you know, $20 or, you know, or less. You get a smaller piece and you get something that's literally 100 times as large. So you can cut any size you want, as many GPUs or CPUs as you desire. You know, you keep this around and just cut out of it as needed, any shape you want. And so this one I think is gonna be my bet. So it's a tiny bit thicker than 0.2 millimeters. It's 0.254. So it's like, you know, 0.01 inch. So as long as it's, you know, not too thick, but again, you want it to be a tiny bit thick, so it adds a little bit of the cushioning fills in the gaps, and if the clamping isn't perfectly even, it will still make good contact. And it has adhesive as well, which is great. And yeah, and then there's also a data sheet if you need it. So, you know, what I like is that there's specifications for everything. They do come in different sizes, and it looks like all these are graphite. Oh, one thing to watch out for graphite is it's electrically conductive. It's not isolating. So some materials that you use for heat sinking are thermally conductive but electrically isolating. Graphite is both electrical and thermally conductive. So if you look down here at the ohms, it's basically 0 ohms. It's basically like perfectly conductive. So make sure that, you know, it's okay if, you know, if that's grounded, it's earth grounded. Make sure that it's okay for that to be touching your CPU. Some pass transistors or LDOs, I've noticed that the heatsink is electrically connected to like the V in or the V out line. It's not ground. You really don't want to accidentally ground it to the case or something through this material. So something to watch out for. So this sheet, there's also a sheet that's much thinner if you know, want 0.127 millimeters. This is the 462 series, 463. Both are in stock. Get a gigantic sheet and you can just cut off pieces as needed. And that's my great search.
That's great church.
Where in the world is that part I need? The great search with DigiKey.
All right, thanks everybody. That's it for this week. We'll see everybody during the week. There's lots of videos and more ahead. Thank you so much. And don't forget to check any shipping times because we have a couple holidays coming up
Tuesday
and
and
more to do.
Friday. Yes.
See everybody
Play
later.
with the holidays. Bye, everybody. Have a great week.